now I will show you how to do docking actually. So this is why I'm actually using PYRX over here. We already cleaned up protein, we already prepared our protein with all things we need. Now we have to go for docking. So for this we are using PYRX. So first of all you have to select your protein what you cleaned and keep it for docking. So I already cleaned and prepared multiple protein, but for now I will select one of them over here. Now you have to convert this molecule into macromolecule, make macromolecule. So we already make this into macromolecule, our prepared protein over here. You can actually okay, there is no chain, but sometimes you can see some chain over here on this ligand. You can actually just delete those chain or deselect those chain if you want, if you have some chain over here, but for now we don't have any chains, or you can actually take all the chains if you want. So we are going to do all the chain over here. We actually don't have any chain over here, so we are going to do for full protein. Now we have to select our ligand, multiple ligand. So for this we go here in open bevel, and now we will go over here to import our ligand. So we already prepared some ligand in our ADME folder. Where is our ADME? Okay, give me a moment. Alright, so here is our ADME. We already done some ADME test on our ligands. Okay, so after ADME we get some ligand that actually break no rules, so we keep those in accepted file, and we get some that actually break few rules, but still we can do docking with this so that we can check out how much they bind with that protein, and then we can actually check out how to solve those problem or the breakout or something. So for now we going for accepted all proteins. These are all accepted protein over here. So let me take one by one. We cannot actually select all the files at once, so let me just take one by one. So here is one, now one more. So after selecting all this protein, I will talk you later, okay, after selecting all the ligand over here. We done loading all our ligands over here. You can see all the ligand we already loaded in our PYRX. Now we just have to right click and go for minimize all, or you can actually minimize selected also if you want, or if you want to do for different for some ligand, as like you can select like this and then minimize only selected, or you can minimize only one or two, or for now I just minimize all. So this minimizing all the ligands energy, and now we get this minimized energy, minimized ligand over here. Perfect. So after minimizing all this ligand, now I have to convert all this ligand to PDB-QT. So convert all to autolog ligand PDB-QT. So now we get all the PDB-QT file over here for all our ligand. Now we go for docking. So we go on Bina Wizard, select molecules. So now let me see, only one ligand is actually selected and the protein is also selected, and here is our all the ligands, and here is all the protein. So I want to select all the ligand from here, so I will just click over here and shift and click over here. So 26 ligand already selected. If you just click one ligand over here, then just press hold shift, then go down and again click on the last ligand, then you can select all of them at once. So we done selecting all this. Now we click on forward, and this will take us to the grid box, so that we can set up the grid box over here. So you can see over here 26 ligand selected and one protein also selected. So we are going to dock 26 ligand against this protein. So forward. So here is our grid box. So if you know any coordinate as like XYZ coordinate, then you can set your grid box as like you want for that coordinate, but here is actually X, Y, Z. You can set up all the parameter over here from here, but I want to do blind docking, so I will cover the full area of this protein so that we can do blind docking over here. So I will just click over here and check out if any area of this protein actually outside of this grid box or not. I will cover all the protein area so that we can do blind docking, and we can check out if any of this actually bind with this ligand or not. So here we done. Now we have to just take it a little bit up and a little bit this side. So this little actually not that much big problem if this out, but still we will fix it. Okay, so in each side no molecule actually outside this grid box, so this is called blind docking. because we don't know any coordinate. Or if you know any coordinate, or you want your binding energy for a desired location, then you can set up the grid box like that. So I think it's done. So after setting up your grid box, you just have to go for click on this forward button one more time, and this will start working. So you see analyzing the binding site, and this will start analyzing one by one for each ligand. So here actually running the second one, first one done, second one done, and running the third one. And after all this done, I will talk to you later. Okay, so our work is done. You can see all the work is done. So which ligand actually have the best binding affinity? Here we can see the energy, binding energy. This one minus 6.5, minus 6.5 for second one. So here is all the data you want. Okay, so here we get 7.6. The best one is actually maybe 8.4 and 8.7. So we already have the ID. Here is the ID, so we can actually check that later, which one actually, which ligand. So now I will just save this. Click on this save as CSV. So I will save this as CSV format, and I will save this in my ligand folder. We do here, so I will make a folder as like results. Go over here, give the file name as what? So binding affinity for all ligand, save. Now if I go on that location where I save the file, so here is the results, and if I open this one, you can see all the binding affinity over here. So here is for the first ligand, all this actually for the first ligand, and all this for second ligand, all this for third ligand, UFF 330, and here is actually the ID 4276 is the ID for this ligand over here. Okay, so this is the binding affinity for all this protein. Now I will just go for any of this ligand and try to check out the binding. So we get the highest binding affinity for this one, 8.7, and this is actually this, and also get another good result for minus 8.4. We need further analysis to validate actually. So here is all our ligands, and now we go for checking individually one by one. So for that we go for Autodoc, and here is all our ligands, and here is the protein we selected. Now we will interpret the result as like we get the best binding affinity for, we get minus 7.5 over here. I see minus 8.7 also, so let me just check out this minus 8.7 only for now. Minus 7.7. okay, here is the 8.7, and this is for the ID 136828 and the energy is actually 610.66. okay, so I will find out that one from here. So here is actually the last ligand that show the highest binding affinity. This one, the ID 136828 136828 so this is the ligand. And now I will go for display, right click and go for display. We get the best binding affinity for this one, 610.66 and 136828. so we go over here, right click over there and click on display. So here is all the binding affinity for all of them, but only first one was actually the lowest, so I only select the first one and select all this. So here is the protein, and now model 1 actually give me the highest binding affinity, maybe. Yeah, the first one. So I will select only this model 1. So here is the best binding affinity for this ligand, and now I can save this, and here actually we cannot see that much good everything, so we can visualize this in PYMOL, or also we can visualize this in Discovery Studio also. So let me just save this. We can check out from here also as like lines, as like okay, but I think the better visualization is from PYMOL or Discovery Studio. So let me save as Autodoc, save as PDB actually. I'll save that over here. In results, and name, maybe I can give the same name as over here, 1368 28302, and binding energy is actually 610.66, and this is model 1. Okay, so let me save this. Now I can open this in PYMOL or Discovery Studio for better visualization actually. So let me just go to results, and here is the this actually not saved properly, maybe. Yeah, this actually not saved properly. .06 is we changed the file format, so not saved properly. So let me just go for one more time. Let me just save with the binding affinity 61066 and save. Now it's save as PDB. Now let me just open this one in our PYMOL. So here is the protein. We can change the name later. Now let me load the protein also. Here is the protein. We take the protein from here, and this one is our protein. So here is the best binding affinity for this protein. You can check out over here. Also we can check out this in various format actually. We can check out over here, and also we can go for Discovery Studio to visualize this. Same way we do the thing in the same way. We load the protein. Now we will load the ligand. Here is the ligand. Perfect. So this is the thing over here. We already define the ligand. Let me select the ligand. We selected the ligand, and this is our protein. Both is selected. Now we can check out the ligand interaction. So the interaction between this one, and this is all the interaction between the ligand, you see. So you can directly check out the interaction from this Discovery Studio. Also you can check out all this from PYMOL also. I'll try to show you, but I think Discovery Studio is a little bit easier, but PYMOL actually give you the better visualization. So both of them actually are pretty good. So this is the interaction. Here is the interaction. Here the bond, and you can check every single interaction over here, and you can check out the bonds actually, atomic bonds, and hydrogen bonds, charges, everything you can check out from here. This is pretty easy. Hydrophobic bond, ionizability, SAS, and a lot more. Okay, so this is the visualization of your ligand protein interaction from Discovery Studio. So let me check out the interaction in PYMOL also. Here you can open the ligand and the protein in the same way. Then you can go for all and this A section and go for preset. Here you can see all the thing over here. Let me just see, or let me just call it not here, preset, class of simple. Simple means you can see a stick line like this. I want actually cartoon, but can see the cartoon format over here. Oh, here is the cartoon. So here is the cartoon format, and now this will visualize perfectly. And if I want to check out the sequence, or in which sequence this ligand actually binds, so let me just select this one, actually this one, and this one also here. This is the whole ligand. If I go for sequence, then I can check out where this actually binds. Actually binds over here. I don't know what. Let me just interpret this one properly. This actually, after selecting this one, this actually binds with this sequence. Okay, so here is the binding and the ligand over here. Okay, so this is our ligand and this is the binding site over here, this one, what I selected now. You can visualize in different format actually. So I think this is it. I will just show you to how to visualize in Discovery Studio. You have other format also. If you click in each of them, then you can see the distance also, you can see the binding affinity, you can actually select the colors of every single, as like if I select the green, then the whole protein become green, or whole ligand become green. If I just want to just change the color of the protein, then we'll go for color and make it red. So the protein ligand is green and the protein is red now. You can change and check out everything from here actually. We can select the main chain, we can check out the binding affinity, we can check out the distance and everything in PYMOL, also in Discovery Studio. So this is it for today.